So I want to review graphing points as well, or graphing lines. So this is Tori's work from Haynes. Shout out to Tori for her great work on this assessment. Here you're given a slope of a line, and you're also supposed to have to pass to this point. So in order to do this, the first thing you're going to do is graph the point you're given. And you can see Tori graphed this point at -4 on the x-axis, -1 on the y-axis. Then she took our slope, which was 1/3, and she used the rise over the run. In other words, she went up 1 and over 1, 2, 3, and plotted her second point right there. She then used the Alex function to create a line on her graph. Oops. And plotted that line right like that. That's how you graph when you're given a point and the slope. Let's take a look at two other problems. Here's one that Tori's only mistake, and this is really helpful. You'll notice here's your equation in slope-intercept form. Y equals 5x, -5x plus 3. Slope-intercept form is y equals mx plus b. M represents our slope. B represents our y-intercept. So if we look at what Tori did here, let's start with what Tori did correctly. She began with B. In other words, she began by plotting the y-intercept here at 3. Now, what Tori forgot is about the slope, because slope is still just the rise over the run. So Tori went down 5 on here. But remember, our slope here is -5, and slope means rise over run. So Tori went down 5. But remember, -5 is the same thing as -5 over 1. So if you plot this first point here on the y-intercept, you would go down 5 and then over 1. And that is what makes your line. Oops. And remember, this line continues in both directions. Struggling with this pointer here. There we go. Right, and it would look a little bit like that. So if you have an integer slope, like -5, remember to make it over 1. So then let's take a look at one more problem. And here you see it says y equals x. Now this looks tricky, right? Because we're used to slope-intercept form where it's y equals mx plus b. And over here, it doesn't seem like there's an m or a b. But let's start to rewrite this equation a little bit. And what if I wrote this as y equals x plus 0? Well, at 0, right, that's where the b is. And any number plus 0 is just itself. So if I were to simplify this, it's just y equals x. So if you see an equation like this, it doesn't look like there's any y-intercept. It's actually the y-intercept is right here at 0. Then it also doesn't look like there's any m, right? Because you don't see any number before x. Well, any number times 1 is itself. For example, 5 times 1 is just 5, right? And -3 times 1 is -3. And x times 1 is just x. So if I were to rewrite this equation again, I could also write it as y equals 1x. Now that starts to look like your slope, and in fact it is. If the x doesn't have a number before it, it's saying the slope is 1. So our slope is 1. And what's interesting here is Tori did this one correctly. She went up 1 and over 1. Right, last time we talked about including the integers being over 1. So she went up 1 and over 1 and plotted her point right there and made her line. So that's just a little refresher on how you graph using slope-intercept form.